Picture this. It's 50,000 years ago, you're hungry, and in front of you sits a mushroom you've never seen before. No Google, no poison control hotline, no older sibling to test it first while you film the reaction for content. Just you, your growling stomach, and a 50-50 shot at either dinner or a very bad afternoon. So how on earth did our ancestors figure out what was safe to eat without a single one of them ending up as a cautionary tale carved into a cave wall? Buckle up, because the answer involves dead relatives, talking monkeys, purple lips, dirt-eating pregnant women, and possibly the world's first Yelp review. Let's get one thing straight right away. Early humans did not have a food safety manual. They had something far more brutal and far more effective: trial, error, and a whole lot of dead bodies. Yes, unfortunately, a huge chunk of how did they know what was safe boils down to someone ate it and someone else watched what happened. Grim? Absolutely. Effective? Also absolutely. This is what scientists politely call the toxic screening method, and what I call extremely high-stakes taste testing with no NDA. Here's the thing though. Humans weren't just randomly biting into every leaf, berry, and root they came across like toddlers let loose at a buffet. Evolution had already given them a built-in cheat code. Taste, specifically bitterness. Our tongues are basically walking alarm systems, and bitterness is the Mayday signal. A huge number of naturally occurring toxins and poisons in plants taste intensely bitter, and our taste buds evolved to treat bitter as a giant flashing warning sign. This is why, even today, most kids hate vegetables like broccoli and Brussels sprouts. It's not because they're picky, it's because their ancient toxin detectors are working exactly as designed. Somewhere out there, a 5-year-old refusing to eat their greens is technically exercising sound evolutionary judgment, and honestly, we should respect that. Sweetness, on the other hand, was basically nature's green light. Ripe fruit is sweet, calorie-dense, and rarely dangerous, so our ancestors developed a strong preference for sweet flavors because sweet things were reliably safe and packed with quick energy. That's also, unfortunately, why modern humans lose their minds over donuts. We're not weak, we're just running very old software in a very new world. And that software has not received a single update in about 200,000 years. But taste alone wasn't enough. Plenty of dangerous plants don't taste bitter at all. Some of the deadliest ones taste completely neutral. Or worse, they taste sweet. So humans needed backup systems, and one of the biggest backup systems was, honestly, other animals. Ancient humans were master observers of the natural world, mostly because they had to be. There was no alternative entertainment. No phones, no Netflix, just watching squirrels for 6 hours straight, because what else are you going to do? And through that obsessive observation, they picked up an incredibly useful trick. If animals were eating it and thriving, it was probably safe for humans too. This is sometimes called the squirrel rule, though I'm fairly sure I just made that name up right now. If birds were feasting on a certain berry bush every autumn and none of them were falling out of the sky, that was valuable data. If deer grazed on a particular plant without keeling over, that plant went on the probably fine list. Early humans essentially treated the entire animal kingdom as an unpaid team of taste testers, which, in retrospect, is a genius and slightly evil life hack. But, and this is a big but, the animal rule wasn't foolproof. And this is where things get spicy, sometimes literally. Some animals can safely eat things that would kill a human instantly. Birds, for example, can happily munch on chili peppers because they don't have the same receptors that make capsaicin feel like fire to mammals. Certain animals can eat plants loaded with toxins that their digestive systems have specifically evolved to handle, while a human eating the same plant would be in for a very bad time. So, watch what the animals eat was a good starting clue. Not a guaranteed safety certificate, it was step one of the investigation, not the verdict. This is where cultural knowledge comes roaring into the picture, and honestly, this might be the real secret weapon. Humans have something almost no other species has: the ability to pass down detailed, specific, life-saving information across generations through language and storytelling. A wolf can't sit its pups down and say, "Hey, 3 seasons ago, your great uncle ate the red berries by the river and it did not go well for him, so we don't touch those." A human absolutely can, and they did, constantly. Anthropologists studying hunter-gatherer societies have found something remarkable: elaborate, detailed oral traditions specifically dedicated to food safety. Which plants were edible raw? Which ones needed to be cooked first to destroy toxins? Which ones needed to be soaked in water for days to leach out dangerous compounds? Which parts of a plant were fine while other parts of the exact same plant would kill you? This knowledge didn't come from one lucky guess. It came from generations of careful testing, painful mistakes, and grandparents drilling the lessons into their grandchildren with the seriousness of a military briefing. Skip the soaking step on that route, and you're not getting grounded, you're potentially dying, so pay attention. And here's a genuinely wild detail. Some of this trial and error testing became incredibly systematic. In certain cultures, when encountering an unfamiliar plant, there was an actual protocol. Step 1. Smell it. Does it smell like something already known to be poisonous? Step 2. Touch a tiny piece to your lips and wait. Any burning, tingling, or numbness? Bad sign, stop immediately. Step 3. Place a small amount on your tongue without swallowing and wait again. Step 4. Chew a tiny bit and wait even longer. Only after all of these steps produced no bad reaction would someone actually swallow a small amount, and then wait hours to see what happened before eating a full portion. This is essentially a slow-motion, homemade version of clinical drug trials, except instead of a lab coat, you've got a fur cloak, and instead of informed consent forms, you've got sheer necessity. This process is sometimes called the universal edibility test, and versions of it are still taught in wilderness survival courses today, which is honestly incredible when you think about it. A food safety protocol developed by prehistoric humans with zero scientific instruments is still considered solid advice for anyone lost in the woods right now, this week, in whatever year you're watching this. Now let's talk about mushrooms, because mushrooms deserve their own dramatic spotlight. Mushrooms are absolute chaos. Unlike plants where toxicity often follows somewhat predictable patterns, mushrooms are basically nature's game of Russian roulette. Two mushrooms can look nearly identical. Same color, same shape, same size. And one will make a delicious meal while the other will shut down your liver within days. There's no consistent bitter equals bad rule for mushrooms either, because some of the deadliest mushrooms in the world taste completely pleasant, sometimes even described as mild or nutty right up until your organs start failing. Because of this brutal unpredictability, mushroom knowledge became hyper-specific and hyper-local in early human cultures. It wasn't enough to know mushrooms can be dangerous in a general sense. You needed to know the exact mushrooms in your exact region, what they looked like at every stage of growth, what they grew near, what time of year they appeared, and how they could be confused with deadly lookalikes. This knowledge was treated as incredibly valuable and was passed down with extreme care because getting it wrong didn't mean an upset stomach. It meant potentially wiping out a chunk of your family in one unfortunate soup. Let's take a quick detour to the coast because seafood introduced an entirely different set of puzzles. Shellfish, in particular, could be perfectly safe for months and then suddenly, without warning, become deadly, thanks to something we now call algal blooms, tiny toxic organisms that shellfish filter out of the water and concentrate in their bodies. Ancient coastal communities had no idea what algae or toxins even were, but many of them noticed patterns anyway. Certain seasons, certain water conditions, certain warning signs like discolored water were quietly associated with "don't eat shellfish right now." Some coastal cultures developed traditions around watching the color of the tide or avoiding shellfish during specific months entirely, essentially encoding a scientific phenomenon they couldn't possibly understand into a simple seasonal rule that worked anyway. It's a bit like your ancestors accidentally inventing an early warning system using nothing but vibes and consequences. Speaking of cooking, let's give fire the credit it deserves, because fire might be the single greatest food safety innovation in human history. Cooking does something remarkable. It breaks down many toxins and compounds that would otherwise be harmful, softens tough plant fibers, kills off dangerous bacteria and parasites, and makes food dramatically easier to digest. Some plants and roots that are genuinely poisonous when raw become completely safe and even nutritious once cooked. Cassava, for example, contains compounds that can release cyanide if eaten raw or improperly prepared. But with the right processing and cooking, it becomes a safe staple food that's fed millions of people for thousands of years. Ancient humans figured this out purely through observation and repetition, discovering that heat wasn't just for warmth or flavor, it was quite literally a detoxification tool. This single discovery changed everything. Suddenly, entire categories of food that were previously too risky or too difficult to eat became accessible. Cooking effectively expanded the ancient human menu overnight, and it's a huge part of why humans were able to settle in such an enormous range of environments, from freezing tundras to dense jungles. If a plant was dangerous raw, but safe cooked, that wasn't a dead end. That was a solvable puzzle, and ancient humans solved an astonishing number of these puzzles through pure trial and error long before anyone understood the actual chemistry behind why it worked. Let's talk about meat and spoilage too, because this is another area where ancient humans developed surprisingly sophisticated instincts. Humans, like most animals, have a strong innate reaction to the smell of decay. Rotten meat produces compounds that most people find instinctively repulsive, and that disgust reaction isn't random. It's an evolved survival mechanism protecting us from dangerous bacteria and toxins. Our sense of smell and our sense of disgust were essentially early biological hazard detectors, working in the background to keep us from eating something that would make us violently ill or worse. But here's an interesting wrinkle. Not all spoiled food is actually dangerous, and ancient humans figured this out too, leading to one of the more surprising food safety discoveries: fermentation. At some point, someone noticed that certain foods left to sit and change over time didn't become dangerous. They became different, and sometimes even better. Milk left out transformed into something like yogurt or cheese. Fruit left to sit developed alcohol. Vegetables left in salty water became tangy and preserved for much longer than fresh versions. This wasn't random luck repeated endlessly. Early humans learned to recognize the difference between "this has gone bad in a dangerous way" and "this has transformed in a useful way," essentially becoming amateur microbiologists millennia before anyone knew bacteria even existed. Fermentation became one of the most important food preservation and food safety technologies in human history, allowing people to store food for much longer periods, which was an enormous advantage for survival, especially through harsh seasons when fresh food was scarce. Now, let's address something people often overlook: spices. Ever wonder why so many traditional cuisines from hot climates are absolutely loaded with strong spices? Garlic, chili, cinnamon, cloves, and so on. There's a genuinely fascinating theory here. In hotter regions, food spoils faster, and historically, before refrigeration existed, that was a serious ongoing danger. Many common spices have natural antimicrobial properties, meaning they can actually help kill or slow the growth of the bacteria responsible for food spoilage and food poisoning. Researchers studying traditional recipes across the globe have found a noticeable pattern. Recipes from hotter climates tend to use significantly more antimicrobial spices than recipes from cooler climates. It's very possible that ancient humans, through generations of trial and error, gradually built spice usage into their cooking, not just because it tasted good, but because it quite literally helped keep them alive. Your grandmothers. Insistence that everything needs more garlic might be 10,000 years of accumulated survival wisdom talking. By the way, if you want to go even deeper into the secret lives of ancient humans, I just launched a full course called The Secret Lives of Ancient Humans. 10 modules, 3+ hours of content covering everything we never talk about on YouTube. What they feared, how they communicated, what hunted them, and much more. Plus an exclusive PDF guide included. Link in the description. See you inside. Here's another one that sounds almost made up, but genuinely isn't: eating dirt, specifically clay. Across many cultures throughout history and even today, there are documented traditions of eating small amounts of specific types of clay, particularly among pregnant women, and particularly in regions where the diet includes plants with mild natural toxins. It turns out certain clays can bind to toxins and plant compounds in the digestive system, essentially acting as a kind of primitive antacid or toxin sponge, reducing nausea and blocking the body from absorbing harmful substances. Ancient humans almost certainly didn't understand the chemistry, but they absolutely understood the results, which is really the theme of this entire video. Understanding the what long before anyone understood the why. Let's also talk about something a little more heartbreaking but incredibly important: pregnancy and food taboos. Across countless cultures throughout history, there are specific food restrictions tied to pregnancy. Certain foods pregnant women are told to avoid entirely. For a long time, some of these taboos were dismissed by outsiders as superstition, but researchers digging deeper found something remarkable. Many of these pregnancy-specific food taboos target exactly the kinds of foods most likely to carry parasites, toxins, or bacteria that are especially dangerous during pregnancy, even when those same foods are relatively low risk for the general population. This suggests these weren't random superstitions at all, but distilled, hard-won survival knowledge, specifically protecting the most vulnerable members of the group, passed down as cultural rules because these microorganisms cause developmental complications isn't exactly a sentence with a Paleolithic vocabulary. Wrapping the lesson in taboo and tradition made it something that could survive being passed down for thousands of years without anyone needing to understand the underlying biology. And this actually reveals something huge about how ancient humans handled food safety knowledge overall. They didn't need to understand why something worked, they just needed a system to remember that it worked. Rules, rituals, taboos, and traditions functioned as memory devices, packaging critical survival information into forms that were easy to teach, easy to remember, and hard to forget even without writing, without science, and without a single lab test. A taboo saying, "Never eat this plant during this season," might sound mystical or arbitrary on the surface, but strip away the ritual language, and often what's left underneath is a precise, accurate, and hard-earned piece of biochemical knowledge, dressed up in a costume so it would survive the journey across centuries. Of course, we can't ignore the darker side of this story because plenty of people did die figuring this out. Archaeological and anthropological evidence suggests food poisoning and plant toxin poisoning were very real ongoing dangers throughout prehistoric human life. Every single food safety rule that got passed down likely had a body count attached to it somewhere in its history. That plant your ancestors avoided, someone probably died to teach that lesson. That mushroom your community refuses to touch, even though it looks harmless, someone probably found out the hard way, and the community made absolutely sure nobody forgot it. In a strange, morbid way, every piece of food safety folklore is essentially a memorial, a lesson paid for in the worst possible currency, and then carefully preserved so no one else would have to pay that price again. There's also a fascinating layer involving children, believe it or not. In several documented hunter-gatherer societies, young children were sometimes allowed a bit more freedom to sample unfamiliar small quantities of plants under close supervision, essentially acting as very low-stakes testers precisely because a small child eating a tiny nibble of something questionable was far less dangerous than an adult eating a full meal of it. This wasn't callous or careless. It was closely monitored, deliberate, and treated as an important part of community knowledge building, expanding what the whole group knew was safe while minimizing the actual risk involved. It's an unsettling detail by modern standards, sure, but it highlights just how seriously ancient communities took the ongoing project of mapping out what could and couldn't be safely eaten. Migration adds another layer to this whole story, too. Every time a group of ancient humans moved into a completely new environment, a new forest, a new coastline, a new mountain range, all of their existing food knowledge was suddenly, partially useless. The berries that were safe back home might have a dangerous cousin here. The mushrooms that were fine in the old valley might not even grow in this new one, replaced by unfamiliar species with unfamiliar risks. This meant that every major human migration throughout history came with an invisible cost, an entire new round of trial and error. An entire new set of lessons that had to be relearned, sometimes painfully, before a group could settle comfortably into a new home. It's one of the reasons early human expansion across the globe wasn't just about finding new land, it was about slowly, carefully rebuilding an entire food safety database from scratch in every single new place. Generation after generation, migration after migration. By the time humans began settling into agricultural societies, thousands of years of accumulated trial, error, observation, and oral tradition had built an enormous, detailed body of food safety knowledge. This knowledge didn't disappear once farming began. It evolved right alongside it. Early farmers had to learn entirely new challenges, like how to properly store grain to avoid dangerous mold growth, or how certain preparation methods could reduce toxins in newly domesticated crops. Many domesticated plants we eat today in their wild ancestral form were actually far more toxic or bitter than the versions we eat now. Humans didn't just discover which wild plants were safe, they also gradually bred and selected domesticated plants specifically to be less toxic and more palatable over countless generations, essentially engineering safety directly into the food supply itself, long before anyone understood genetics. It's worth pausing here to really appreciate the sheer scale of what was actually accomplished. We're not talking about one group of clever ancestors figuring out one clever trick and passing it down forever. We're talking about thousands of separate human communities, scattered across wildly different environments. Deserts, rainforests, Arctic tundras, mountain ranges, tiny islands, each independently building their own local encyclopedia of what was safe, what was dangerous, what needed cooking, what needed soaking, and what needed to be avoided entirely depending on the season. None of these communities were in contact with each other most of the time. There was no shared global database. And yet, over and over again, completely independently, humans arrived at strikingly similar solutions. Taste as an early warning system, observation of animals as a first clue, oral tradition as long-term storage, cooking and fermentation as detoxification tools, and taboo as a way of preserving lessons too important to risk forgetting. So when you really step back and look at the full picture, the answer to how did ancient humans know which food was safe isn't one clever trick or one genius insight. It's an enormous layered system built from evolved taste instincts flagging bitterness as danger and sweetness as safety, careful observation of which foods animals could tolerate, detailed and specific oral traditions passed down with real urgency across generations, systematic testing protocols applied to unfamiliar plants, the transformative discovery of cooking as a detoxification method, the surprising benefits of fermentation, the protective use of antimicrobial spices, the strange but genuinely effective practice of eating certain clays, and cultural taboos functioning as memory devices to preserve hard-earned lessons, often at a devastating cost. It's genuinely one of the greatest ongoing science experiments in human history, except there were no lab coats, no clipboards, no safety goggles, and definitely no consent forms. Just curiosity, hunger, close observation, and a stubborn refusal to let painful lessons go to waste. Every time you season your food with garlic or chili, every time your body physically recoils from the smell of spoiled milk, every time a kid refuses to eat something bitter and green, you're witnessing tiny living fragments of that ancient, hard-won knowledge still, quietly operating in the background of everyday life, completely unnoticed, doing its job exactly as it has for tens of thousands of years. And honestly, next time you're standing in a grocery store complaining about how there are simply too many cereal choices to pick from, maybe take a moment to appreciate that you get to make that decision without any real risk of dying from it. Somewhere back down the family tree, someone else did the dangerous work of figuring that out for you. One bitter bite, one bad mushroom, and one very cautious nibble at a time.